This media was gratuitously produced by Clear Contributions Audio and Video. The intellectual property contained within belongs to Dr. Barbara Van Kyken. Clear Contributions. Let's have clarity.
1 year I kept picking up the same marker that didn't write, and I, set it down, I'd pick it up again, and I got really frustrated with it, and so I thought, this has got to go. So I threw it to the back of the room. There's a little trash can back there. And I threw it to the back of the room, and it went in. And so that's the, oh, am I cool or what? Hey, that was great. And so the next time that happened where a marker didn't work very well, I thought, I'm going to see if I can do that again. But you know how if you try too hard, you let go too late because you're trying to lob it too hard? And so I was standing up here, and I'm really putting some punch on it to get it back there. And I let go of it too late, and I hit the student who's sitting right about where Damon is here. Just hit him right in the chest, just boom! And I said, oh, Jared, I'm so sorry. And so I picked it up, and I thought, okay, don't let go so late. Don't let go so late. And so I wind up, and I threw it, boom, right into Jared again. And so I gave it one more try. Everybody on this side of the room is ducking under the desk. And Jared's just sitting there looking at me, just smiling. And I just went, boom! And I decided I'm not doing that anymore. All right, let's see. A is this one. All right, any disagreements with this? All right. 4, 5, 6, 7, 8. That's true. That's an octane, and that's all the question asks for. I realize that, but just because you know now how to name all the substituents and everything, what would go where in addition to the octane? Dimethyl octane. Very good. Okay, good. Let's see. B is this one. You guys actually went in order. How thoughtful. Why is this one an ethane? You have 4 carbons over here. It's got to be attached to the functional group, right? So, yep, that's an ethane. Great. Since you are really struggling with this whole concept, I'll kind of try and force you into this. What would be the name of that substituent? Butoxy. It's a butane because it's got 4 carbons with an oxygen, so that's butoxy. All right. And what would be the... Okay, I'll just put it down. Okay, and what would be the ending for the functional group? Good. Okay. This is great. You picked the correct parent hydrocarbon, I should say, but it's my bad. It's my fault. I didn't teach you one other thing, so we'll fill in the blank now. This is a hexane because it has 6 carbons, but notice that looks different than if I did the 6 carbons like this. Right, it's a different kind of group. So if it's in a ring like this, it has cyclo in front. Okay, so I realized that was my foul up, but that's how that works. And then the group attached to it is propyl. Okay, good.
It's E is on the right side there.
Yep. Very good. So you have to choose either the chain or the ring. This has 7 carbons in it, so that's decidedly the parent hydrocarbon. All right, now I haven't shown you this before, but using reasoning and logic, that's one thing I'm going to try and build in you. What do you think the name for this substituent is?
Cyclopentene? No.
Close?
Pentyl.
Cyclopentyl. See, that's one thing I love about organic chemistry. It follows the same pattern, so once you know the pattern, you can... Like I said, I know that you didn't fill in the substituents. I know it didn't ask you for it. I'm just trying to work you here a little bit. All right. What is the issue with this? You can't come up and then go over and then around like this. It has to be a continuous line without backtracking or anything. And so because of that, this is actually your longer. Chain there. The rest of it becomes a substituent, and you don't know how to name that substituent yet, so we're not going to worry about it.
I drew it so starting from the left and then at the CH go down.
And that's fine. Oh, down here?
Yes.
No, that's going to be shorter, because this is only 2 carbons here, and this is 3 coming this way. Is that correct?
Yeah, that's good.
And it's still happening.
Yes.
Right, and then CH2 is still not.
Come to the right and go down.
You can't include all 3.
Could you go that way, or is that good?
So that's 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. It's 6 any which way you go there. Okay, F. The double bond is a functional group, so you have to include any carbon that's directly attached to the functional group, which translation is if you have a double bond or triple bond, you have to include both of those carbons. And so even though this isn't the longest carbon chain possible, it's the longest carbon chain that contains a functional group. And so you have chain right, and then you've got the substituent attached to it. And the name for the substituent is propyl.
I have a question. So it doesn't matter how many hydrogens are attached to the group, because like with propyl, that refers to the three hydrogens in a substituent setting. But there's 3 carbons, sorry. But there's 3 hydrogens on one and 2 hydrogens on another. That doesn't matter.
No. It's just the number of hydrogens you need so that the carbons have 4 bonds.
Okay.
So all you're looking at is the carbons. Good question. Okay, last one. So you got your functional group here. You have to include both of those carbons, which means you have to go through the whole thing. So you have to pick either this one or this one as part of the parent hydrocarbon. This is correct because it's got more carbons. And then this has more carbons than that one, so it does come that way. 2, 3, 4, 5, 6, 7, 8, 9. It's based on a non-name. And now just for extra practice, we'll fill in the rest of it. Your substituents are methyl and butyl. And remember, you put those in alphabetical order. And the ending that you want for this would be double bond is an ene, and since it's no longer an alkane, you drop the whole ane ending and put ene on there. Butyl methyl non-ene. All right, now do you have any questions about anything? Anything I can help clarify? Okay, on page 10, you also had some homework. I'll run down through the answers for those, and then you can ask me if you have any questions about that. Going ABC right across the top row. Substituent, functional group. Substituent, functional group. Substituent, functional group, substituent. Yes, ma'am.
I was confused on the fourth one
Mhm.
because isn't that an ether?
Mm-hmm.
That's still not a functional group.
I know.
Okay.
I know. Doesn't that make you bitter?
Well,
An
then-
OH is a functional group. An oxygen with carbon is not. I don't know. Let your bitterness work for you. And yeah. So to remember. Okay, then for the appropriate substituent name or functional group ending, what I wanted you to do there was come up with the component name for, if you're going to put everything together, to come up with the whole name of the molecule. And so therefore the chlorine becomes chloro. It's a chloro group. And then methyl, methyl. And then OL ending is what you'd put on for that, for the OH. D is methoxy. A methyl group with oxygen, methoxy. E would be a YNE ending, fine. F is amine.
If it has a nitrogen bond, you just put amine at the end of the word?
Uh-huh.
Oh, okay, cool.
It could have other carbons attached, or it could just all be hydrogens. It doesn't matter. It's still an amine if it has a nitrogen attached to the carbon.
And if there was a carbon attached, it would still be the amine?
Mm-hmm.
Okay.
G is fluoro. H is an ENE ending. And once again, you drop the whole ANE and put ENE. And then I is an ethyl group. Ethyl. All right, anything else?
So on B, on that one,
Uh-huh.
I put ane. That's incorrect, right? It has to be methyl.
Methyl. Yeah, because that's a substituent group. The parent hydrocarbon would still have an ane ending to it, but this is specifically asking you if it's attached to a parent hydrocarbon and you're naming it as a substituent,
Okay.
in which case it has a YL ending. Anything else I can help you with? No? All right, then we'll tackle step 4 today. See if we can work through it. It's the last step for this chapter. And so after today, it's just a question of practicing, and I have a ton of practice for you, just so that you can put everything all together and feel confident and happy about everything. Here's the idea. Right now you know how to name all the different components and find them, but that still doesn't complete the picture because, for instance, both of these are an alcohol, both of those are a pentane, both of those would have the same root name of pentanol, but they're different because the alcohol group is attached to a different location on the parent hydrocarbon. So you have to give directions on where everything is attached to the parent hydrocarbon so that somebody would know how to construct the same molecule. It isn't good enough to just always number from left to right because molecules don't just stay in one place. They flip around, they rotate. There's different ways that you can draw them. It's kind of like saying, there we go. This molecule, see, it's 4 carbons from the end here, but I could flip it around and now it's 3 carbons if you're counting from left to right every time. And because molecules can tumble and flip around, you got to have the same name for the same molecule, not just how it's drawn or how it's flipped. So the convention to make it consistent is that you always number the parent hydrocarbon in both directions, like this. Starting from each end. And then you select a numbering system between these two, so you're not giving both numbers. And you select the numbering system that gives the lowest number possible to the carbon directly attached to the functional group. So if I selected this numbering system for this, and I'm selecting this numbering system here for that, I'm coming up with the same name for the molecule no matter how it's drawn. Once you have that, then if you have the components written out like we've been doing so far, you put the number, the location number for that particular functional group right next to it, or for the substituent or whatever, right next to that substituent. Actually, now if you look at a bottle of shampoo or, different things, you'll notice all these numbers and dashes and everything, and that's all it's doing is it's saying this all group is attached to carbon 2 of the pentane functional group, or parent hydrocarbon group.
So that would be pronounced pentane 2-all?
Yep. Yep.
Pentane 2-all.
Uh-huh.
I might be missing something. Why is it pentane if there's only 4 carbons attached to the function group?
There's 5.
So how would you draw the parent hydrocarbon? Because it has to attach to the function group, right?
Yeah.
Has to include the one that's attached.
It doesn't have to
No,
start.
it doesn't
have to start.
Gotcha,
Yep.
gotcha.
Okay. All right, that's the rule. So coming back to your lecture notes now, page 11. How to correctly select the numbering system for designating the location of each substituent and functional group attached to the parent hydrocarbon. Number in both directions. Choose the numbering system that gives the lowest number possible to the carbon directly attached to the functional group. Number in each direction. Choose the numbering system that gives the lowest possible number to the carbon attached to the functional group. So now you see another reason why I'm having you labeling the functional group in a different color, because this is all dependent on the functional group once again. It deserves special priority. So in organic chemistry, you always look for the functional group. Okay, so I've got an example there for you. We'll work through that. So we're actually going to work through all of the steps, all the way through naming the whole thing now, putting it all together. So you have the OH functional group. Find the functional group first, because the parent hydrocarbon and the numbering system both depend on the functional group. Then you find the longest continuous sequence of carbons that contains the carbon directly attached to the functional group. I did that in black. Why? I don't know.
Oh, I thought this was interesting. I was like, oh
Yeah.
no.
I'm just too
We're gonna
busy
have a black one.
talking. I'm too busy talking. All right, here's the parent hydrocarbon. Leftovers are substituents, and it will only be halogen, a carbon, or an alkoxy group. Okay, so that's step one, identify. Step two is to name, or write the name for each component. And you're going to be doing substituents, parent hydrocarbon, and then the functional group. Okay, in that order. So the name for the substituent is
Bromo.
bromo. Okay. The parent hydrocarbon. Okay. Okay, and then the functional group ending. OL. Step three is how many. If you have more than one of a functional group or of a particular substituent, you don't. And step four is to number in each direction, and you're giving the lowest number possible to the functional group. Or to the carbon directly attached to the functional group, I should say. All you're looking at is right here. You don't care what that does to the numbering with this. You're not concerned with giving the lowest number possible to something. You're giving the lowest number possible to the functional group. So we're going to pick, for this, we're going to pick the numbering system that gives the number 3 to the alcohol. Once you choose a numbering system, you have to stick with that numbering system, otherwise it's meaningless. So if you're picking 3 for this, then this has to be 6 for the bromo group. So then you put the number next to the designation for that attachment. So the 3 goes in front of the all, and the 6 in front of the bromo.
So which direction you name depends on the functional group? Or if there are multiple functional groups?
We'll be doing that next semester, but you go with the lowest number possible for one of the functional groups, and if you have an absolute tie, then you have to start thinking about priorities and stuff.
Why did you put 6?
Sorry?
Why did you put 6 bromo?
Because the bromo group is attached to carbon 6, since we have decided on this numbering direction. You're telling where the bromo group is connected onto the parent hydrocarbon, and the way I've numbered this is carbon 6.
Okay.
So you're looking heptane 3 all or just heptane?
Heptane, yeah. Thank you. Good job. Any other questions? You've worked all the way through it. Good. This is the same thing every time. We have a couple of tiebreaker rules here to go over, but that's it in a nutshell. All right, so the important point that was illustrated by this is that you're looking for the lowest number possible for the functional group, not just for a lowest possible number, and that's one of the reasons, one of the other reasons why it's really helpful to highlight in different colors so you're not distracted by like, oh, look at there's a bromine over here.
So for a double bond, would you just do the carbon that's lowest?
What a great segue. I think that's what we're doing next.
Okay. Oh yeah.
Anything else about this? No? All right. We've only been in class 4 days and already you've blown through chapter 1. You guys are terrific.
Okay, what exactly makes a halogen?
Anything in this column right here.
Okay, anything column, no, column
70 or 17, depends on the periodic chart you're looking at. Yeah. Okay, we'll walk through this up to the point of writing the number in. And I'll let you do it. I'll let you do the first. I'll let you do all the way through the 4 steps here, but then as far as writing the number in when you've got the name, I'll help you with that. Oh, what have I done? What have I done? What have I done? Pay attention, huh? All right, did you get that far? Yes. Okay. Notice that there's always 2 numbers describing where a double bond is. But they always have to be sequential. 1 and 2 or 3 and 4. So when you write the location number for a double bond, you write the lower of the 2 numbers in the numbering system that you've selected. By implication, it's got to go to the next higher numbered carbon in the parent hydrocarbon chain. So this would be but1ene, for instance. Same thing is true for a triple bond. It has to be between 2 adjacent carbons. So you pick the lower of the 2 numbers. By default, it has to, or by implication, it has to go to the next higher number. You still got anything left in you?
Oh yeah.
Oh yeah. All right. An example on the top of the next page. I'll let you see what you can come up with first.
Is it a
Everybody else.
No, anything after it's a substituent.
I know, it's I don't know why, but there's something confusing all of a sudden when you have carbons on both sides. It just throws your brain for a loop. Yeah.
And you can't go through the opposite.
True.
Okay.
Pick one or the other. Remember that the functional group or substituent does not have to be attached to an end carbon.
What's the name for 3 carbons? Is it propane?
For some reason you have an answer? What is that supposed to mean?
I don't know what to do when the carbon's up. I was thinking of 1, 2, then jump to the top 3, then go down 4. But no, okay.
It has to be in order. It has to be in order of the sequence of carbons.
Yeah. No idea. Gosh, I love this class, dude. It's so much fun. Would you start 1 at the top and then 2 at the beginning?
You gotta go both directions. So if that's your parent hydrocarbon, then it goes 1, 2, 3, 4, or 1, 2, 3, 4. Now you go in a sequence.
So you put 2 lots of butane. Is anything else get that? Oh, wait. Yeah.
You're so suspicious.
So you don't need to name the functional group. Numbers for functional groups don't matter.
They do, but this doesn't have a functional group.
I meant not functional.
A substituent?
Substituent.
You do have to number the substituents, but this one you don't have a functional group, so you don't have any way to decide based on that.
Yeah, I didn't too, dude.
two right here.
No. So you add the 2 in the name, as you were saying before, because you're changing your oxy, right? So what was this before you put oxy on it?
Propane.
Propane. Right. So you cross out the A's, right? You put the 2, then does that make sense?
Yeah.
Perfect. You add the 2 just inside the name, just
Okay,
just
gotcha.
making sense.
Let's see how you did. So when you have an ether, you have to see which carbon group on ether side of the oxygen is longer. So it doesn't have to be attached to the end carbon. So just count how many carbons you have in a sequence there. So that makes the butane side here, this parent hydrocarbon. So now if you're writing this in, butane goes here. This is a substituent, as bitter as that might make you, it is. That's all I can say about it. This is propane, right, but it has an oxygen. So it becomes prop-oxy. Okay, you don't have more than one of a particular substituent or functional group, so now number in each direction. 1, 2, 3, 4, or 1, 2, 3, 4. This time you don't have a functional group, so actually we're going to a tiebreaker rule where you are just giving the lowest number possible. Then if there isn't a functional group present, you just have to go with what you have. So this propoxy group is attached to carbon 2 of the parent hydrocarbon, and so then you write that out in front, and there's your name. How did you do?
Wait.
Did you get it?
Why do you have it in the front?
Because that's a propoxy group. This is all one name for this one group. So I'm saying that whole group is attached to 2.
It's been in the back because you've been attaching it to functional groups. And we're not.
So attaching it at 2, does that imply that the 4 is above, or do you just the carbon above is number 4?
No, so since I picked this as 2, that means I've got this numbering direction here. So the carbon above it, technically, if you needed to say that something was attached there, that would be carbon 1. It probably bugs you seeing it like this. You could alternatively draw it like this, and it would be the same thing. This is just a bond rotation kind of thing. Those are equivalent.
Do you always put the number in front or no?
Yes, you always put the location number in front of the substituent name or in front of the functional group ending.
So the name...
There's a couple of minor exceptions that we'll go over, but to tell you the truth, if you put a location number every time, I won't mark you wrong. There's a few cases, though, where it isn't necessary. But yeah.
So location number responds to what it is. So like on our last example, the OH, when put into heptane OL, full, you added a 3 in front of the OL to show that it's attached to the 3rd carbon.
Of the parent hydrocarbon. That's right. No, it sounds like you got it. That's good. Any other questions about this yet? All right. I keep asking because I've got one more thing to throw at you, and I don't want to have this little where your brain just exploded because it's like already overloaded. All right, I'm going to leave that up on the board while I put the next example up then. Okay. So with the next example, you have nitrogen, and it could just have the parent hydrocarbons attached to it, but you could have 1 or 2 additional carbon groups attached to it. But it's the same issue as for the ether. If you got multiple choices, pick the one that gives the longest continuous carbon sequence. And so since this is an example to compare and contrast, I made the parent hydrocarbon look the same. Okay, and that's attached to the nitrogen functional group. And then you have two substituents here.
The dot line, is that signifying?
It means that I was having a hard time making the graphic look right on the drawing program, and that was the lame way that I made it work out. It should just be a solid line. Okay, so identify the different parts, then write the names down for everything.
It's nothing. This was your body kettle. You know that. Yeah. You named it Stanley. Stanley's tumor.
And of course you put the substituents in alphabetical order since you have more than one substituent there. You don't have more than one of any kind of functional group or substituent, so we'll go on to numbering the parent hydrocarbon. Always numbering the carbons in the blue, starting with one end and working towards the other, and then coming back the other way.
How do you know what to name the substituents if they're connected to the functional group instead of the parent hydrocarbon?
That's where I was saying this is one more thing I'm throwing at you, mind blown kind of thing, but we'll get there in just 1 second. So you have the amine attached to, or the nitrogen attached to carbon 2. I'm going to put the 2 out in front here. All right. You can't give a parent hydrocarbon location number for things that are attached to the nitrogen instead of the parent hydrocarbon. So what kind of designation do you think would tell somebody that it's attached to the nitrogen, not the parent hydrocarbon? No?
You're not labeling it?
You can add amine to the end of the name.
No? So if you had a 2 here, for instance, that would imply that they're also attached here. You want to say it's attached to the nitrogen. What short abbreviation could you put here so that you can tell somebody it's attached to the nitrogen? An N. There you go. If it's attached directly to the nitrogen, you put an N. Uh-huh.
Not like look at shampoo bottles now.
So I'm
People get so confused when they look at they're like, oh, this doesn't make any sense. Well, it does. You just never get class.
Yeah.
I have a question. The amine, so you were talking about how the functional group alcohol, amines, alkene, alkynes are dead. So like back here, when would you add amine like the end of a name? So that's what it would look like then?
Mm-hmm. And that's why I'm having you do it like in these kind of steps so that you don't get confused and, put other kinds of...
So if that butane, if that was actually, there was a double bond or a triple bond, you'd add the E or the Y in it? Is that at the end? Oh.
Always. It's a little pattern.
Alright, you drop the E even though there's no longer two vowels together?
Yeah, it kind of, it's...
So like the number, even if there's a number there that breaks up into 2 vowels, you still need to drop the vowel.
Okay.
Would you ever mark this?
Nitrogen is the only functional group that's going to have substituents attached to it, right? So that's the only one that you're going to have to write the letter.
That's right. And so that's why I put the comparison here. For even with oxygen, you can only have one other group, and so if you say this is a propoxy group, you've already described that whole group, whereas this you could have multiple substituents on it. So this example, you put an N. This one, you don't put an O because you already put oxy.
So it doesn't matter if it's like ammonia or ammonium, it's just still just N. Okay.
So why don't you add amine at the end of the name instead of like as you do with oxy, you add oxy at the end of the name. Why don't you add amine at the end of like the E?
Because you already got the amine here. And this is a functional group. This is a substituent. It's classified different. That's the one you guys keep coming back to with the, wait, an ether's not a functional group. I have issues with that. I know. So does everybody else. Well,
So does
this is just how it is. Yes, ma'am.
Could OH be in the place of N?
No, because oxygen can only have the 2 bonds. So either it's an OH, in which case it has an OL ending because it's an alcohol, or you have carbons attached to it, in which case it's an ether, alkoxy substituent. And so those are the only 2 cases. So you can't have multiple kinds of things going on here. You don't have those 2 issues. This you could have all different kinds of things happening with the nitrogen. Yes.
How did you come up with these
2, so that'd be alphane, but when it's a substituent, change the ending to YL.
Thank you.
You're welcome. I really, really hate to do this to you, but no, I can come up with homework. Okay, I don't want you to go over the weekend without doing some homework because you're going to forget what we did, but I also want to go through the tiebreaker rules before I have you naming stuff. But on page 31 and 32, I have the name for you, and you can practice drawing the structure from the name. And that will kind of get you some practice with working with the nomenclature stuff. Okay? Have a good weekend.